find a voltage drop across and currents reach resistor in the following circuit. Use Kirchhoff's rules showing the direction of the current voltage drop and use your work to validate the circuit and your checks and values and your checks that the values have been correct. So let's take this as a node and let the current flowing over here is I1. So let's say I2 moves over here and I3 moves over here. And let's say this is the loop 1 and this is the loop 2. So let's use Kirchhoff's current law at A because the net current has to be 0. So I1, which is incoming, should be equal to I2 plus I3, which is outgoing. Let's use the KVL at KVL, Kirchhoff's voltage loop rule, in loop L1. So that's going to be 22 because that is positive. That is along the current, so that will be negative I2 R3, where R3 is 2 ohms. And then this is opposite to the current, so that's going to be plus 4 I1, and that is equal to 0. So we rearrange, then 22 minus 2 I2 plus 4 I1 is 0. Then let's move this over on the right and divide both sides by 2. So this will be 11 is equal to I2, 11 plus 2 I1, which is from these two, and that should be equal to I2. This is equation 1, this is equation 2, and then we apply KVL in loop 2 as well. So we get opposite to the current, so we have negative 1 I3, so that's just negative I3, and plus 10, and minus, because along the current, minus 4 I1, that is equal to 0. So if you rearrange, then I3 plus 4 I1 is equal to 10. Let's call it equation number 3. In fact, let's isolate I3 from here as 10 minus 4 I1. Let's call it equation 3. So if you notice carefully, from second and third, we can write I2 in terms of I1 and I3 in terms of I1. So let's put it in equation 1. So basically from 1, 2, and 3, we'll get I1 is equal to I2, and I2 is nothing but 11 plus 2 I1. And I3 is 10 minus 4 I1. So I1 will be equal to 11 plus 10, which is 21. So 21 minus 2 I1. Adding 2 I1 both the sides, we have 3 I1 is equal to 21. So I1 will be 7 ampere. Uh, and I1 is 7, it means that we can easily find I2 and I3. So I2 will be equal to 7 times 2 is 14. 14 plus 11 is 25 ampere. And hence the value of I3 will be 10 minus 7 times 4 is 28. 10 minus 28 is minus 18 ampere. So that's in the exact opposite direction. So let me just change the direction of I3. I mean, I'll just clear everything up and now denote everything. So I1 is 7. So initially this was I1. So let's clear I1 first and let's write it as 7 ampere. So this is 7. Then I2 is 25. It means that here we have 25 ampere. And I1 is negative. So I1 is in opposite direction as 18 ampere. So this is coming as 18 ampere over here. So the potential drop will be like plus and minus here. This is plus and minus here. And this is also plus and minus here. So we got the current in all the three resistors. Thank you.